よし。さてと、なんもねえ。クローンして。シンクコールバック。非同期だから 違う。ファイル。深海はこれをもう一回やるとあ、そっか。間違はないと。シンクプロミス。やるにはファイルを読み込んで、読み込む。 ロミスでプロンプトで読み込む。ここでやってるのは、握手をすり込むです。In the file explorer view as pure like this。これか。これを実行してみる。握手、URL でコンソール。URL データを読み込んでみましょう。ですね。とりあえず、これをよくには、NPM で、握手をするモジュールを読み込む。はいはいはい。まあ、行きましょう。やると、プロミスに一回ペンディングして読み込んで成功する。接続が404で失敗すると。この場合は、404でページが見つからなかったと。なるほど。Working with sales のJSON パース。今までは JSON が生だったけど、クラウドアプリケーションデベロップメント。JSON パース、これか。楽勝してデフォルトで JS のデータを読む。 JSON そのままのやつをストリングファイルにして、ある程度読みやすく形を整えてやると、例えば、これが間違っている場合、2とかやるとエラー出ます。その場合は当然、あれだ、セーブじゃないからダメか。もう一回、404が出る。読めるけど、例えば、ここをコピーして、そのまま、こうすりデースを出してみるとする。パースしたわけやな。そうすると、ああ、オブジェクトとかそのまま出ちゃうわけね。それを防ぐためには、異次元配列を読み込みにすればいいと。Async await API ランダムハウスからとりあえず動かしてみる。await API ジョン・グリサムで検索すると、ペインチドハウス、タイムトゥーキランダムハウスでこれをや出しているというわけね。同じく。同じだけど、アシンク、プロミス、アクシオス、リスト。ここで実際、リクエストを URL です。レスポンスが、タイトルどうする？それだけ選べばする。これ、A 新起動機だから、アプターだってからだってことなのか。A シンクキャッチ。 同じく、ランダムハウスで、グリシャムを見つけるのが一緒。アクションスケットした。ノード。これが全部出てくると。出てくるのがここで。リクエストレスポンスが、マップ、ワークがプロミスアトリビュートでワーク ID ごとでいいので、これをやっていくと。なるほどね。じゃあ、全員アシンクをしていると、多分ここは、チェーンがこれ順番だったのと違って、こっちは A シンクだから順番がバラバラになると。OK。じゃあ、そのラブのネクスト行きましょう。ここはそのネクストでいいや。You have completed response. Network page run in asynchronous manner and can block user to handle the threat from a network call. You can write a callback function that Node.js calls when the network operation completes. If you have multiple asynchronous calls, there must be a callback function for each level. Promise builds are most useful for operations that are time consuming and can block resources. JSON pass and JSON string are two methods used to handle JSON objects. ネットワークオペレーションアシンクロナスでやりましょうと。正解。We are right to callback to run for each of the following events. あなたが書いたコールバックファンクションはいつ実行されるか。その Node.js がメッセージを受け取ったとき。はい。Another event. HTTP リクエストか。Where in the callback function does the Node.js pass the error? ファーストパラメータで返してくると。クエスチョン表。What do you use response end for? これがレスポンスが終わったときはね。 Question 5. What do you use to convert the JavaScript object to JSON string? JSON string file. OK。全部で1、10点と。こういうと。金は払わん。安ければいいけどね。いや、安いんだけどね。When you use Node.js to build a hypertext on the Cousera server, you will discover that the default Node.js framework is so stable. You can extend its features with third-party package. Get hands-on experience by using the Express Web Application Framework. Express を使うと。Discover how to manage package dependencies. Create a web server that listens to incoming requests. Use routing, middleware, and template rendering to extend the Node.js framework and handle dynamic client. Node.js. After completing this module, この講義が終わると、you'll be able to send an HTTP request to get the HTTP request をデータを取得できる。Learn how to use libraries to abstract low-level tasks. Low-level task. Import LP's package to manage Node.js package in a Node.js framework installation. Import Express module and create an Express application. Use routing, middleware, and prevent and request repeatedly in activities like authentication. Checking session information and filling the content in front-end application. さて、まあここまでは EdX をやったから次行きましょう。マイクラス少しは出た。ユーザーシティで見つけた。What do you want to select to get our discuss? ジェネラルノーレッジビルディングでいいかな。コーセラとかやってます。いいでしょう。コミュニティは使ってないかわからん。こんなもんだかな。1時間。よし。インタラジェス。これですよ。
Let's look at front-end versus back-end. So you're sitting at your desk and you load up a website. Let's say you typed out https.udacity.com. Now, out in the world somewhere is a server. This is the front end. This is where a front-end developer works, on the browser. A back-end developer works on the server. If you're developing for both sides, then you're a full-stack developer. So you type out that website, that goes out to the server does its thing, it chugs away, it gets that information, and then it sends it back. Some front-end languages might be HTML, CSS, and JavaScript. Back-end languages are Python, PHP, even JavaScript again, Ruby, and many, many more.
The front end.
Let's dig a little into the front-end languages. But before we look at front-end languages specifically, let's take a little dive into programming languages. If you do a search for a programming language on your favorite search engine, you might come across some of the words like abstraction, or data structures, or flow control. Now, these are helpful if you actually know what a programming language is and it helps you to communicate with another developer. But if you're just sitting there and you're like, I don't really know what a programming language is, these words aren't really going to help you much to understand what a programming language is. Basically, a programming language is a tool, so it's a set of written instructions. It's a tool to help you tell the computer what to do. So you use this tool, you write out the written instructions, you write out the code, and then that code will then tell the computer what to do. So that, at a very high level, is what a programming language is. Programming languages, they have data that they manage. Some of the data could be usernames, passwords, location. If you had written out a bio on a website, that's some information. Programming languages also have data structures. For example, a list of things. So right out here, I've written out eggs, flour, and milk. This would be considered a data structure because it's a list of items. There's also comparing a list to a key value pair. So a list is just a list of things. A key value pair would be like firstborn is Richard. So I'm the firstborn in my family. So if someone says, who's your firstborn? That's the key. The value of that would be Richard. So that's a different kind of data structure from a list where it's just a list of straight items. Here is a key value pair. The next thing that's in a programming language is flow control. So do X, whatever X is, if Y, whatever Y could be, is true. So you just do this thing if this other thing is true. There's also until A breaks and stops working, keep doing B. So see how there's this we're deciding what we're going to be doing. We're deciding the flow of the program based on these values, based on these information. So do X if Y is true, or keep doing B until A breaks. So we're deciding things. There's information, we're keeping this logic, and we're controlling the computer through the data and the flow control information. So that's kind of programming at a high level. And again, it's a tool, these written instructions that you use to tell the computer what to do. So having said all of that, let's look at the front-end languages. So a front-end developer works here on the front end in the browser. But what is exactly in that? What do they actually have to do in all of that? I like to think of it as a house. And there are three main sections to the house. There's the structure of your house, so that forms the rooms, the shape of the house, how many floors are there. Then there's the looks of the house. Is it going to have some red paint on the outside? Is your interior going to be some cream color? What color are the cabinets? That's the looks. And then the functionality. Is there some alarm system? Do you have some automation built in? When you get home, your garage door automatically opens. That's the functionality of the house. So I like to think of the house as having three main sections. If we convert that over to web technology, the HTML is the structure of your website. So it's the holding up the pieces of the web. Then there's the CSS. This is the looks. Is this thing going to be blue? Are you going to have a red background? Are you going to put it in the top right corner? Where is it being positioned? That's CSS. It's deciding looks and placement of things. Then JavaScript controls the functionality of the page. When I click on a button, do some images get loaded? That's JavaScript. It controls the functionality. So the three main pillars of websites are the structure, which is controlled by HTML, the looks, which is controlled by CSS, and then how does it actually function? That's the JavaScript. Let's look at HTML. Here I have a code editor with some HTML inside of it. Now, HTML stands for Hypertext Markup Language. Now, even though we just looked at programming languages and kind of did a little dive into what a programming language is, HTML is not a programming language. HTML kind of just states out what it wants. Here is the information. There's no flow control. It doesn't really have data.
データ付けしてないよと。
That it maintains. So HTML is not really considered a programming language, but it's one of the main languages for the web. HTML, as in its name says, it's a markup language. And that just means it's regular language here, but it's like text-based, but it's marking up the text with these extra special characters, as you can see here on the right. And it is made up of tags. And here are some of the tags. They're all highlighted in blue. So on the right-hand side is the HTML code. On the left-hand side is the representation of that HTML when it's rendered in the browser. Let's take a look at some of the pieces here of the page. So we have this input tag, and then we have the rendered view on the left-hand side of the input tag. We have the text filter visuals, and then we have filter visuals on the left. Then there's an input of type checkbox, and then we have the input checkbox right there. And then down here we have the heading, the H1 main visuals, that's a heading. And then on the left-hand side we have the actual text main visuals, and it's big and bold like a heading. Here is some CSS. CSS stands for Cascading Style Sheet. And like HTML, it is not a programming language. There's no control structures, there's no flow control, there's no real data. You just kind of state out what you want and it just does it. So it's not really a programming language. CSS is made up of rules. And we can see a rule right here, visual item, and then there's an open curly brace, and then 3 lines. These are the rules inside that visual item rule. And it says cursor should be a pointer, padding, which is just space around, we should add some spacing, and then we should center align the text. So here's a little bit more of that same render view, and then here we can see some of the CSS being applied to that page. So we can see that there's the word headshot, and then there's a little mouse cursor right next to that word headshot. And typically what you would see is that there's the little arrow of the mouse, but because in the CSS on line 46 we say cursor is a pointer, now it's got the little hand instead of the little angle mouse cursor. There's this rule down here that says visual item : hover. So when we hover over the visual item, set the background to this EE, that's a special color code in CSS, and so it's going to set it to this light gray color. And so if you look over at the rendered output, because the mouse is hovering over the headshot one, there's this gray border around it as opposed to screencast next to it, which has this white, clear, see-through background. So here we're just stating out the rules. Our visual item will have these rules, and then when we hover over it, our visual item will have different rules, and we can see those being applied to the rendered output in the browser. Let's move on to JavaScript. JavaScript just is JavaScript. Sometimes you'll see it abbreviated as JS, but typically it's written out as the full word. And JavaScript is a programming language. So we have HTML, CSS, and JavaScript. JavaScript for the front-end technologies is the programming language. And so we can see here, I have highlighted a list of things. So we're keeping track of some data. So like we had with programming languages, we went over, that is a list of information. It keeps track of lists of things. Here is a list. We have HS, and then a comma, and then SC, and then a comma, and then an A. So this is a list of information. We also had that flow control. Here's the word if. So we're checking things. Remember, if X happens, then do Y. Here's an if statement, and so we're saying if, and then there's a bunch more code. So if this thing is true, do something else. So JavaScript is a programming language that will let us control the page and do things.
実際に今のアプリに表示されましたと。コストミニバックエンドラン。
Let's look at backend languages. Let's look at backend languages. So the front end had HTML, CSS, and JavaScript, which were the structure, looks, and functionality. The backend language, well, there are actually a lot of backend languages. There's Python, PHP, Java, .NET, Ruby, and actually, even though JavaScript is a front-end language, it's also a backend language. So here at Udacity, we have the Full Stack Nanodegree program, and in the Full Stack Nanodegree program, we cover Python as our backend language. And here is some Python code. And we can see that this is a programming language, just like JavaScript. And here we have an if statement, which will again do that flow control, where if something is true, then do something else. So here it is in Python where we have if, then some code, and then it'll print the word blast off. So what does a backend language do? Why would you want to pick a backend language? Backend languages do data processing. They determine what files to send. They determine what content to put in those files. And they help build up the HTML, CSS, and JavaScript that get sent back to the front end. So they do a lot of this data management and getting information and packaging up the information and then sending it back to the front end. So seeing the big picture again, a user is sitting at their computer and they pull up a website. In the back somewhere out in the world is a server. Your browser requests some information from that server. The server does its thing and chugs away at getting the information and processing it, and then it sends a response back to the user, back to the front end to get displayed. So for this section, we looked at front end versus back end. Then we looked at some of the back end languages, which are HTML, CSS, and JavaScript. And then we looked at that there were a number of back end languages, with the primary one for us here at Udacity as Python.
So next.プログラミングの全体像っていうのがここです。さて、今日JavaScript。あるんでね。Start. You run the powerful tool in JavaScript. Control flow is powerful invoked that giving users to do some when this proves will be magic eight. Yeah. こうされていきますよ。そして配信をこっちに切り替え。Java プログラミングと 試合のところ28日30時間。行きましょう。モジュールランアウトカムズ全体像で Web サーバーログスモジュール。In this module, you will learn about how web server logs store information about visitors' lives, and you will write programs to access information like user IP address, date and time of access, and more. Using the programs you write in this module, you will be able to read information from a web server log, count the number of unique visitors to your website, and count the number of times each visitor used your website. Our course resource はここでちゃんと全部読めるようにして、プロジェクトリソース、ブレッドライブスを使ったログはエントリークラスウェブサーバー logs from logs to visit example です。こういうやつを使えと。アイコンしかねえじゃん。まあ、とりあえずここら辺は、エデュケーション。そうして、そうして、エグザンブルファイル、ログ1っぽい。そして、ウェブログ1。エントリーで同じく。コースを使って、ここに戻りやると。さて、まずは、ここにログを、ショー、やりますよと。
Now, you're going to write some programs to analyze web server log files. Most major web servers log each access to a file, which records who made the request, when the request was made, what the request was, and how the server responded. So why would you want to analyze web server logs? A web server's log file lets you understand a lot about how your website is being used. You might want to know how many people are visiting your site. Is it popular or not? If you have many different pages, are they all getting traffic or only a few? Understanding how your site is being used is particularly important if you are trying to make money off of it. Popular pages bring in revenue, while pages that nobody looks at are not helping your business.
The log file can also be useful in diagnosing problems, as it will tell you when your server is experiencing errors. If one of the pages isn't getting traffic because a link to it is broken, you want to know so you can fix it. In the rest of this lesson, you're going to work on code to read the contents of a log file. Being able to read the contents of a log file will set you up to solve a variety of problems, such as figuring out how many different visitors have come to a website or how many times each visitor has visited the site.
というわけで、これでいいならね。なんか、あ、ギャランティーは入らないか。これで OK と。アンダースタンディングログファイル。あ、実は開示が入ってる。入ってない。
Welcome back. Now that you know about the importance of web server logs, it's time for you to start thinking about writing code that deals with them. The first thing you're going to want to do is to be able to read in a web server log file and represent the information in it in Java objects. To do this, you need to think about two things. The first is, what does all of the information in the web server log mean? And the second is, how do you represent it in a Java class? Here, you can see one entry from a web server log file. It has a lot of information, and it's not readily apparent what each piece means. To find out what it means, you would want to read documentation about this web server. This particular data came from the web server log for an Apache 2.4 web server. So to find out more, you could go to Google and search for Apache 2.4 web server log file format. If you do that, you'll end up with a lot of hits, and this first one here gives you a link to the Apache documentation site. If you scroll down a bit, you'll find the information on the access log, that is the log of accesses to the web server, which is what this web log is, and you will see that it has information about each of the pieces of this entry. The first is the IP address, that is the address of the device on the internet which made the web request that is logged here. The next two pieces are both dashes. That indicates that they're missing information. The first dash is for some information about who made this request, which you'll see the documentation says is unreliable. The user's computer could lie about who they are. The second dash is for the username if they're logged in with HTTP authentication, if they've typed a username and password on the website. The next piece of information is the date and time when the request was made. Next, you have the request itself, including what type of request it was, in this case GET, where they're asking for a particular web page, and then what page they asked for. Next is the status. Here, it says 200, which indicates success. There are many other statuses which indicate success or failures. You may be familiar with 404, which is code that indicates that the requested page was not found. Finally is the number of bytes that the server replied with, how much data it sent back to fulfill this request.
そうやね。あれWhen reading a web server log, the IP address refers to the IP address the site that is being visited. あ、そこそっか。そういうことか。 ポジティブだからね。
Okay, now that you've read the documentation and understand what each of these pieces of information mean, it's time to think about how to represent them in a Java class. The first thing you need to think about is what type of information each of these is. For the IP address, you could use a string since you're interested in just the text of that field. Java does have a built-in class for IP addresses, which would give us some more features if we wanted to actually connect to that address, for example, but we don't need that functionality, and we don't need to worry about the complexity that would introduce right now. We don't need to represent the two fields that we've omitted that have no useful information. We do, however, want to represent the date. You could use a string for that, in which case you would just have its text, or you could use the built-in Java date class, which understands what dates and times are and how they relate to each other. So you could check if one time is before or after another time. For the request, you can just use a string. And for the status and number of bytes, those are both numbers, so you can use an int. Now that we've thought through these types, it's time to turn this into some Java code. Here, you can see the start of a Java class for a log entry. We've declared a public class log entry and written fields based on the types that we just discussed. You should now think, should each of these fields be public or private? Remember that if a field is public, any piece of code can access it, and if a field is private, only code within this particular class can access it.
Private にしたいけどね。
In this particular case, it makes sense to have each of these be private and to design your class to be immutable. Remember from earlier when we learned about strings that immutable means you cannot modify an object once you create it. So you're going to write this class so that each of these fields will be set in its constructor but can only be read. To make anything able to read these fields, you'll write a public getter or accessor method such as these, which will just return the value of that field, but there will be no way to set the value of the field once it's constructed. Speaking of constructing, you need to write a constructor for this class. There are two ways you could do it. The first is to take in this entire string and then have the constructor pull it apart into each of these individual pieces and fill in the fields or instance variables of the class. The other is to have the constructor take each piece of information separately and simply initialize the fields of the object. We're going to have you do the second one, just making a constructor that looks like this, which is going to fill in the fields based on the information passed in, with each piece being passed separately. Why would you do it this way? Well, this gives you a little more flexibility. If you wanted to create one of these objects from some other source of information, you could do so. It turns out that pulling this line apart is actually a little bit tricky, so we're going to give you the code for that. It's a little bit ugly, and we'll package it up into a nice method for you so you can just use it to read the file. Here's the final log entry class with all of the things you just learned about. You would use this to represent one of these log entries as you work with it. So your next task is going to be to use this class, the code we give you to split this up into each separate piece, and put them together to make code that's going to read the entire log file.
Hi, so today what we're going to do is we have this log entry class, and I want to show you toString. So the log entry class, notice it has these 5 fields here, IP address and so on. We've got our constructor, and we've got all these methods. And I've written toString down here, and you can see that it returns those 5 fields as one big long string. And what I've done is I've got a tester over here that is creating two log entries, LE and LE2. And I've just kind of made up some information for each of them so they're different. And then it prints out the actual object. It prints out LE and it prints out LE2. So let's run it and see what happens when we do this. So I'm going to come over here. Notice I need to compile both of these. I'm going to compile tester. And it actually compiles both of them for me. I'm going to now run tester. Test log entry, and there you can see it printed out the 5 pieces of information for each log entry. Very nice. So now what I'm going to do is I'm going to come back to my class, and instead of calling it toString, I'm going to change the name. I'm going to call it getLogInfo. And compile it again and run it. And let's see what happens. So I've got my object, and now I'm running test log entry. Oh, so I ran it, but it just printed out something else. Let's see what it printed. It actually printed out the memory location of each of those objects. So let's go back to test our tester here, and you can see when I print out an object, LE, it doesn't know how to print it out. So it just prints out its address location. It's not calling the method we wrote, which is called, let's see here, right here, we called it getLogInfo. It's not calling that because we didn't specify it. So let's come back over here, and we'll specify to print out a log entry with that method. We need to actually write log entry dot get log info. And I'll just do that for the first object, and I'll leave the other one, LE2, like that, and let's see what happens. We'll compile it, and we'll come over here and run tester. And so you can see what here in for the first object I called getLogInfo, and it calls getLogInfo, and it prints the 5 pieces of information. But for the second one, I just said print the object, and so it just shows the memory location of it. So what's going on here? It turns out that every class has a toString method by default. But it only knows to print out the memory address of an object, unless you actually specify a toString class. So I'm going to change this name back to toString. And I'll come back over here in our tester and get rid of this. Because notice, I didn't actually call toString here. I just said print out the object. And again, if I show you what happens here, we don't need the, there we go. So we're just going to print out the object. We're not saying how or anything, but it just knows, go look in my class, and if there's a toString method, that's how I'm specifying how I want to print it out. So again, we call it here. And even though I didn't call toString, it knows, it says, oh, you've got a toString method, so I'll use yours. And it prints out the 5 pieces of information the way I specified I wanted the object printed out. Now I want to show you one more thing. I'm going to come over here. That name toString is very important. It has to be spelled exactly toString with a capital S, because I'm going to show you if you change it to lowercase s, so it says toString, then when I come over here and I run it, let's see what happens. It goes back and prints the memory address, because it says if there's a toString in there spelled with a capital S, it's going to use that. but that's the only thing it looks for. Since I don't have it spelled correctly, it doesn't find it. And so it says, I'll just print out the memory address location. So just remember that all objects have a default toString method, and if you don't like it, it's just going to print out the object address. Then you can write your own, and so when it runs, it'll see if there is a toString method in there, then it will call it. That's it. That's for toString. Thanks.
トゥーストリングについていろいろとか。そしてまずは。
Hi. Now that you've made your log entry class, you need to parse the lines of the web server log to be able to create instances of the log entry class. You'll do this by splitting the string into the appropriate fields to pass values to the constructor for the log entry class. You could accomplish this task with many index of and substring calls. Although this task is not algorithmically hard, the code for it is very cumbersome. For example, for the time portion of the entry, you would need to turn the string into a date object, the built-in Java class from the java.util package, which represents a date and time. Even though both the date and time class, as well as methods which parse strings, are part of Java, the interface to the date class is complex, especially since the date format in the server logs is not the default format in Java. For these reasons, we've provided code for you which will take a string from the web server logs, parse it into appropriate fields, and return a log entry record. To use this, call weblogparser.parseEntry and pass the string you want to parse. The method returns a log entry object. With that in mind, it's time to turn your attention to starting to write the log analyzer class. For right now, you're going to write code in the constructor to initialize the object, and then write the readFile method. In later lessons, you'll write additional methods that will perform the actual analysis of the log file that you've read in. The first thing you would do to fill in the code for the constructor should initialize the record fields to an empty array list. You've created array lists in the past, so what you need to accomplish this task should be familiar. The second thing you should do is fill in code for the readFile method. This method will determine the file name to read from, and then add log entries to the records field to reflect the information from the file you opened. To accomplish this task, you will want to make a file resource for the requested file. You will then want to iterate over the file resources lines. And for each line, you will use the weblogparser.parseEntry method to convert the line of text into a log entry. Then you'll add that log entry to the records field, which, as you may recall, is an array list. When you've written the constructor and the readFile method, you'll want to test out your code. We've provided a convenient method called printall, which will print all the log entries you've stored in the instance variable records. Remember the toString method that we taught about? System.out.println will make use of that toString method to represent the log entry as a string. Once all this works, it will be time to start analyzing the data you've read in. Happy coding!
一番大変なところはライブラリーでやってことか。
In this lesson, you learned a bit about web server logs, which can give you a lot of information about your website. You learned what is in them, how those records are formatted, as we looked at the Apache web server documentation together. And then you learned how to make a log entry class based on the information in that file. As part of that, you learned about toString, which is an important Java concept, as you will want to write a toString method in many of the classes you create. Finally, you wrote code to read in the log file using the parsing code that we provided. Now you are ready to write some code to analyze the data you've read in.
できますか。 Workspace. Right. 時間がかかるのは仕方ない。さて、Git スイッチ。さて、まずは、アナライズか。ウェイク03に、K、エクササイズのリーディング。ここはここに作っといて、データさ、これ分けるようにかけないようにして、さっきのダウンロードでだけだとこ文字コードはマミックスで問題なしと。次だからここに後で考える。ウェブログショートが入りますと。さてと、で、学習用教材は、リーディングログで、ブルージェイを起動と。さてと、 習いと。これも同じように。こういうところをしっかり書いておかないと、後が大変になる。イメールだと。つまりこのログエントリーはと。コンパイルしても、まあ、それぞれやったコンストラクターと、インデックスをストーリー。というわけですなと。で、テスター。テストエントリー。変わらず テストでログエントリーとすれば、結果がこういうところですが出ますと。さて、ここまでやって、これはバックにありますねと。さて、新規クラス。全部とりあえずここは消して。デューク大学から分かればいいので、とりあえず英語で確認する。これは一緒。これによると、リソースフォームに移動して、チャートで、プロジェクトリソース。パスワード使うかな。これは、バック。違う。ドキュメンテーション。イメージピクセルレンジ URL リソースか。CSV パース。まあいいや。で、プライベートリスト。 コンストラクターで、リスト。これから、テストログアナライザー。大丈夫？
お昼何食べるんだったっけ？
さあ。
まだお昼に早い？
うん。テストログアナライザーメソッド。まずここに。点々のデータスの。はい。でね。ショートテスト。これで一応いいのか。そして、コンパイルでシンボルが抜けられてませんから、アプリトブはサブルーズして、バグアナライザーの のパターンを常にやってるから、そして、で、これ151だから、ファイルリソースの FR 点ラインズ。FR 点ラインズ。とりあえず、
警察官とかなんとか言ってなかった。
聞こえない。僕はかけてるから。
ちょっと自粛が甘い。お花が出た。
これでブログパースは入ってない。JTD 入ってないのか。ソースコード。っていうかそうじゃないんだよ。ASL。じゃあとりあえずブログパスワードを手抜かして、これで、データを、わかりやすくするように。 ストリングとかいいんでしょあれ、ステージでしょデュークリソース。ソースを見てみないとダメかな。Java Web あった。GitHub に入ってるわけじゃない。これは自分のじゃないのか。じゃあ、このあたり調べることもしておいて、とりあえず今回はここまでと。